Welcome to the Florida Water Stewardship Program. I'm Nick Taylor with the University of Florida IFAS Extension, and today we're going to talk about Florida's water supply. In 2023, the average daily water demand in Florida was 6.8 billion gallons per day, and the population was 22.6 million. Florida's population has continued to grow by about 1,000 people per day ever since the mid-1980s. And with the population growth, we have land use change. On the left-hand side, we see a semi-natural area that's used for livestock grazing, and on the right side, we see land being converted to residential development. With the change in land use, we have changes in the waterscape. When you have natural ground cover, like on the left-hand side, you have as much as 50% of the water being infiltrated into the ground and 10% running off and 40% evaporating. But on the right-hand side, what we see is the urban setting with 75 to 100% impervious surface, where only 10 to 15% of the water can actually infiltrate. The majority, 55%, runs off and 30% evaporates. Our growing population means we're going to have more and more of this urban landscape. So what you see on the left-hand side of your screen is our 2010 baseline. All of the red areas are developed areas. On the right-hand side, you see an estimate of the developed land that will be in Florida in 2070, as we move from a population of 18 million in 2010 to a population of 34 million in 2070. This slide shows the water use and how it's expected to increase from 2020 through 2040. In the blue bars, we have public water supply. Public water supply refers to water withdrawn by public and private water utility suppliers that then gets piped out for residential and commercial use generally. In the green bars, we have our agricultural water use, and that largely refers to water used for crop irrigation or for livestock. As we move forward in time, what we'll see is a larger portion of our water will be used for public water supply, and a shrinking amount of water will be used as agricultural lands get converted over to developed land. Water resource caution areas are where existing water sources are insufficient to meet our projected 20-year demands. And you'll notice from this slide that most of the areas of Florida's peninsula are within water resource caution areas. This trend will continue as our population increases. Now we're going to talk about alternative water supply. So how do we get the water to make up for this increasing population? So our traditional source of water in Florida is our groundwater. We have amazing springs and an amazing groundwater resource. And in this image, you see someone down in a cave, and they're literally in the aquifer where we get most of our drinking water. That's our traditional supply. And then our alternative water supply just means non-traditional sources. And just a note at the beginning, these are usually more expensive. The first one we can talk about is reclaimed water. That's treated wastewater that gets reused. It's not drinkable or potable. It gets used for irrigation, groundwater recharge. There's some industrial processes that can use reclaimed water. And a thing to note is that Florida and California are really leading the way in reclaimed water use. The next water supply is aquifer storage and recovery. This is when you take wastewater and you treat it and then inject it down into the aquifer, generally along the coastline, and then bring up fresh water further inland. So this has a couple of benefits. It requires no land. You don't lose water from evaporation or seepage, but you just have some mixing loss as that fresh water mixes in with the seawater. There's another benefit is that it actually pushes back the seawater to reduce bad effects from saltwater intrusion. Here are a map of the aquifer storage and recovery well locations in Central and South Florida. You notice there's high concentration of active well fields around the Tampa Bay area. So the next one we'll talk about is groundwater recharge. This is where you apply stormwater or reclaimed water to an upland area or a wetland. This then filters down into the aquifer. It restores or creates semi-natural areas. And we see this often in multi-use areas, parks and things like that. This is a natural setting, a natural way that our water gets treated and turned into groundwater. Desalination of brackish groundwater and seawater is just removing the salt from the water. From the map, you see around 150 desal plants all along the coasts of Florida and some a little further inland. Those inland places are pulling water from the lower Florida aquifer where it's a little brackish. Florida leads the nation in desal, and some of the good things about it are that it's not dependent on our rainfall. Some of the bad parts are that it's very high energy use and very high cost. It generates a high salinity byproduct, which can be hard to deal with. While it's not technically an alternative water supply, we should consider conservation. It's our most cost-effective option, and we're just talking about being more efficient and less wasteful with our water, and being more conservative with the water that we use. With that said, conservation alone will not be enough to meet the future demands, according to water managers. Surface water can be an alternative water supply. We can take water from creeks, rivers, and lakes to use. It takes more treatment and it can be limited during dry seasons. On the other hand, we can also build surface water storage. The image you see here is a constructed basin, basically a large bathtub where we can collect water during the rainy time and store it for use later when it might be drier. So now that we've looked at our options for alternative water supply, let's talk about what's being done. Where are we putting our alternative water supply efforts? This graph shows funding for each type of alternative water supply project since 2005. The total funding so far has been $11.43 billion. On the graph in dark blue, you see the total funding from the state. That's from the Department of Environmental Protection. In the aqua color, you see funding that comes from the water management districts. And then in green, you see the project sponsor match, which comes from utilities or local governments. So 25% of the total funding went to surface water and surface water storage projects. 24% went to development of reclaimed water systems, and 15% went to funding the development of brackish groundwater desalination. How much additional water does this effort and expenditure gain for us? The dark blue shows water made available to date, and the light blue shows the additional water that will be available upon project completion. We've generated a lot of water with AWS already. That's been 1.14 billion gallons per day. That's mostly from reclaimed brackish groundwater and surface water sources. Once all the planned projects are completed, there will be a total of 1.87 billion gallons per day generated. Again, it's mostly from the same sources. Reclaimed makes up 36%, and brackish groundwater and surface water projects make up 21% each. And now we can combine this information to look at the cost benefit. This graph shows the cost of increasing water supply by 1 gallon per day using each of the alternative water source strategies. The most cost-effective solutions are water conservation and aquifer storage and recovery. Those methods cost around $2 to increase supply by 1 gallon per day. As we think about the alternative water supply, we should think about planning. And planning is usually done by the water management districts. Florida has 5 water management districts: the St. Johns River Water Management District, Suwannee River Water Management District, Northwest Florida, Southwest Florida, and South Florida. These districts don't align with our aquifer generally. Our Florida aquifer covers all of Florida, portions of Georgia, and portions of Alabama. In Florida, we do have some inter-district water supply planning. We have the North Florida Regional Water Supply Partnership, which covers part of St. Johns River Water Management District and part of the Suwannee River Water Management District. That's up, think about the Jacksonville area and sort of northeast Florida all the way down to kind of Gainesville. Then we have the Central Florida Water Initiative. That covers the lower portion of St. Johns Water Management District and portions of South and Southwest Water Management Districts. And that's right in the middle of the state around the Orlando metro area. So when we take that up a level, we can think about the interstate water supply planning. You might also notice that aquifers don't follow state boundaries either, and neither do surface waterways like rivers and lakes. So we're also seeing a move toward more interstate water supply planning, but not yet in the Southeast. One well-known example of the problems this can cause would be the water wars among Florida, Alabama, and Georgia regarding who gets the water from the Apalachicola-Chattahoochee-Flint River system. The green asterisk shows where the river enters Florida. This issue has been in and out of litigation for years. When thinking about water supply and water supply planning, it's helpful to remember two concepts. One, everything is connected to everything else, and two, everything goes somewhere. This leads us to a concept that's gaining traction in Florida. One Water, integrated water management, lets us think about drinking water, stormwater, and wastewater, and how those are all resources for our use. And we should manage all of those water resources as if they are one resource. Notice on this slide, there's the cloud of climate change. That's because we don't fully understand what our weather patterns will be like going forward and how that might impact our surface water and groundwater resources. We broaden this concept of one water. We can then begin to connect energy. When we flip the switch, we also turn on the tap. That's because it takes water to create energy. And when we turn on the tap, we also flip the switch because it takes energy to provide water resources. And if we broaden that concept even more, we can include our food system. Now we're talking about the water, energy, and food nexus. These are all tightly linked, and what you do to one will affect the others. There are trade-offs, but with any solution, you have to consider the other two parts of the triangle as well. So I'll leave you with some questions. What are the plans for future water supply in your area? Do you live in a water resource caution area? Do you live in a one water community? And what can we do to help ensure a reliable future of water, energy, and food supplies for people and ecosystems?